Take a look at these trees. What causes tens of thousands of seemingly ordinary insects to gather in such massive, dense formations? From a distance, they look like thick bark, but up close, you can see individual monarchs clinging tightly to one another to survive the winter. This spectacular phenomenon is fading. Monarch populations have dropped significantly over recent decades, and researchers are desperate for accurate data to understand exactly why. To gather that data, a specialized curriculum turns standard classrooms into operational bases for real-world conservation. Working as field agents, these students train to track and solve a global ecological mystery through direct observation. To understand the mission, we first have to understand a biological anomaly. Most monarchs born during the summer only live for 2 to 5 weeks, which is just enough time to breed. This timeline shows a break in the pattern. While early generations live less than a month, the fourth, super generation, halts reproduction, living up to 8 months. This conserved energy gives them the stamina to fly 3,000 miles south before winter freezes the north. A moment of wonder. The true mystery here is their navigation. These butterflies are traveling to a highly specific forest in central Mexico that they have never visited before. Learning how this supergeneration survives against the odds is the crucial first step for students before they can attempt to help protect them in the wild. The training curriculum starts by examining the insect's anatomy, specifically looking at its early life as a caterpillar. At this stage, the insect is incredibly vulnerable. To survive, it relies entirely on a single food source, the milkweed plant. Milkweed contains natural toxins. As the caterpillar eats the leaves, it absorbs these toxins into its body, making it poisonous to predators looking for a quick meal. Those toxins stay in their system through adulthood. The iconic bright orange and black wings are actually a biological warning sign, telling birds and other predators to stay away. Grasping this absolute reliance on a single plant teaches students exactly what vital resource they will need to restore in the field later on. Zooming out to continental geography, multiple flight paths originate in the north, funneling together into one major route through central Texas. To navigate, monarchs rely on the sun's position and the Earth's magnetic pole as an internal compass guiding them south. Their final destination is the high-altitude Oyamel fir forests in central Mexico. These forests provide a specific atmospheric pocket. It works like a survival buffer. The air stays damp enough that the monarchs don't dry out, and while the trees keep the butterflies cool, they protect them from ever dropping into a lethal frost. To maintain that essential warmth, the monarchs physically cluster tightly together, blanketing the bark of the trees. By tracking this perilous geographic journey, students can pinpoint exactly where habitat disruptions will be the most fatal to the species. Today, the migration path faces 3 severe threats: expanding urbanization, shifting climate patterns, and agricultural pesticides that are wiping out the milkweed supply. To fight back against these threats, the curriculum moves out of the classroom and into action. Students participate in action projects to build monarch way stations. By pressing native milkweed and nectar plants into the soil, they create critical fuel stops for the butterflies along their migration route. Once the gardens are planted, the final phase begins. Students act as citizen scientists, hunting through their new way stations for live monarch eggs and caterpillars. This digital map shows the impact of that fieldwork. Every time a student logs a sighting, a glowing dot appears, connecting into a sprawling data network across the continent. Professional researchers rely on this student-generated network to track population health and migration timing in real time. This work shows that local actions have continental consequences. Planting a single seed in your community can help protect a species 3,000 miles away.